In this module, we're going to talk about the second law of thermodynamics. Our objective of this module is to understand the second law and to see how it applies to chemical systems. One of the things we look at to determine spontaneity is a measure of the disorder in the system. Here are some examples of some spontaneous endothermic processes. This means that our enthalpy values are greater than 0 and we're having to put energy in to make them happen, but this can still be a spontaneous process. Above 0 degrees Celsius, ice melts. To go from the solid to the liquid phase, I have to put energy in. However, I also see an increase in the disorder of those molecules as I melt the ice. Evaporation of liquid water to gas phase water is a spontaneous but endothermic process, as is the dissolution of sodium chloride or other ionic salts in water. When we dissolve those salts, we're spreading those ions around. There are more ways for them to be arranged. We're increasing the disorder, therefore we're increasing the entropy of the system. If I go from the liquid to the gas phase, that is also a spontaneous endothermic process. Because I'm taking water molecules that have some order about them, albeit less than a solid, but I'm taking them to the gas phase where there is virtually no order. There are more ways for those molecules to be arranged, therefore I'm increasing the entropy of the system. As the KBr dissolves in water, the ions spread out, increasing their disorder and increasing their entropy. There are more ways for those ions to be arranged. So let's backtrack a little bit and talk about the first law of thermodynamics, which says energy cannot be created or destroyed. We know from this that the total energy of the universe is constant. Now we can transfer energy and convert it from one type to the other, but ultimately the sum of all those energies must be equal to the same constant value. The second law of thermodynamics is a little bit different. Instead of talking about energy, we are talking about spontaneity, specifically talking about entropy. And what we know is that for any spontaneous process, the entropy of the universe increases. Processes that happen spontaneously are those that increase the entropy of the universe. So although parts of a process may not be spontaneous, when we look at the entire system and its surroundings, what we find is that overall there's an increase in the entropy of the universe. And that's what makes a spontaneous reaction spontaneous. This will depend heavily on the temperature, and as we get later in this unit and talk about Gibbs free energy, we'll be able to quantify that. Next, we're going to go more in depth about what entropy really is.